Hello, good morning. Thank you for inviting me and allowing me to come and present to you today. As we were discussing internally about the seminars that were coming up for today and tomorrow, we're discussing life safety systems and how they've changed in our world. And the fire alarm system, for example, is not the fire alarms that we had from 20, 30 years ago. It's not just we detect smoke, activate some relays and turn on the sounders and alert people. We're doing so much more with that. So that's kind of where the presentation is coming in for the next 20 minutes or so is based on that. You know, as we look at our codes that are out there, NFPA 72, the National Fire Alarm and Signaling Code, it's used globally. It's not just a US document. It's used in Central South America, it's used in Northern Africa, all through the Mideast. And it's an encompassing document. And you could argue now that a fire alarm system really should be reclassified as a life safety system, no longer a fire alarm system. Some of the things that have changed or have been added in our code: auxiliary service provider. When a fire alarm system activates, it needs to alert the building occupants, but it also needs to alert first responders to let people know that they need to go and help assist in evacuation and help to extinguish the fire. That used to be a signal was sent to a station somewhere, and then somebody intervened, picked up the telephone, and contacted the first responders. The human factor can now be removed. Codes now allow a fire alarm system to send signals directly to the first responders, to civil defense, so they can understand how many devices have been activated, where have they been activated within the building, and while they're transporting themselves to the scene, they can start to develop their response plan. So it's more than just saying this facility at this address has an alarm, respond. Another one that's been added is acoustic leak detector. I'll talk more about that in a few minutes, but we now have devices. Acoustic leak detection is nothing new in our world, right? We've had that for years. We can tell if there's a water main break, where it is underground. We can use detection methods to pinpoint that. When a pipe is cracked or leaking, the sound that is from the water or air escaping is a high-pitched, a high-frequency sound, and we're able to detect that, and that's now been added into the code. Speaker before talked a little bit about cybersecurity, and cybersecurity has now been added in for our fire alarm systems, our life safety systems, because again, they're doing so much more than they used to, that now we want them to be integrated with the building information system and other things within our world. And we're not so much worried about a bad actor gaining access to the fire alarm system to do harm with the fire alarm system, like you saw with the fish tank system or the HVAC system, but more it's a vehicle that allows somebody to gain access to critical data on the building owner's infrastructure. As we look in our world, there are some people that have severe autism, cognitive issues, where when a traditional fire alarm goes off, the sounds are so loud that it causes them to do the opposite of what you want them to do. They don't evacuate, instead they go under a desk or go hide in a closet, particularly with children. To help combat that, NFPA 72 has added in restricted audible mode operation, or they're affectionately calling it RAMO. It allows us to reduce that audible mode so it's not as an intrusive thing, and we can educate or work with those people on that spectrum to help them to evacuate facilities better. It also is able to be used in places that house animals, like zoos or places where when the animals are in cages, these loud sounders go off and the animals can be put into stress, so we don't need to do that. When we talk about cybersecurity in Chapter 7 for the documentation side, we need to start engaging with the building owner. Cybersecurity is not just and I am a manufacturer issue. I play a big part in that on the products that I create. But once they're installed, how they're updated, how they're maintained, the building owner plays a big part in that. And what NFPA 72 has done is they've addressed how the building owner now needs to start looking at their maintenance plan when they're adding IT equipment, who has authorized access to gain that could get into those areas, and having logs and updating those logs. And is the right person allowed to go into areas where that IT equipment is located? As our life safety systems are becoming more and more complex, we're doing so much more with them today. We're not just doing fire alarm, we're doing mass notification, gas detection, weather event, and many, many other things. And we're integrating them now digitally with other systems in a building. Days of old, we required in NFPA, they required that you had to be qualified to work on these systems. They've modified the qualifications to say, you know, as these systems have become so large, are you qualified to work on the other things that integrate with your system? You know, it's one thing to be certified by the manufacturer on the make and model of a specific control unit, but once that's networked together and we're sending information to the HVAC, we're remotely doing diagnostics, is that person qualified to work on all those pieces of equipment? So they've drastically modified that. And something as simple as the batteries that we're using. Today in our world, you can buy anything from anywhere in the world, and quality sometimes suffers. Just because it's cheap doesn't mean it still does the same thing as a more quality product. So one of the issues that has been experienced in our life safety realm is the batteries. As simple as it is, the batteries have become, or some batteries are causing problems on our power supplies, and NFPA is addressing that by saying the batteries now that are used in your life safety systems now need to either be component recognized, where I go to a testing laboratory and get them cross-listed or compatibility listed with my control unit, which nobody's doing right now, or use batteries that are listed to UL 1989 or UL 2054 for standby battery and commercial household batteries. And I just have listed there some of the major manufacturers that already have that listing. But something as simple as the type of battery that you're putting in is starting to cause problems with power supplies and chargers in our industry, so much so that NFPA had to address that. I had up there the effective date, January 1st, 2024. In the latest edition of NFPA 72, the effective date has been removed just because 2024 is come and gone. So now when we look at cybersecurity, and our life safety systems play a big part in this when they're connected to the outside world. One of the things that came up, though, from us manufacturers was there are some systems that do not have any ability to have connectivity to the outside world. So that has been addressed in NFPA 72, that if your system doesn't have the ability to communicate or connect to the outside world, it doesn't need to meet any cybersecurity levels or requirements. But when your system does have the ability, there are things that we need to adhere to. So you need to develop some type of a network connectable equipment software production program. How can I prove my system, as I've manufactured it, designed it, installed it, meets cybersecurity requirements to the engineer, consultant, the building owner? So NFPA looked at that and they came up with a few ways that the world is using today. One is from NIST, that you can prove your infrastructure meets these requirements. NIST is the National Institute of Standards and Technologies in the United States. They have a document for framework for improving critical infrastructure on cybersecurity as a way that you can go and validate your system. The International Standards Organization, ISO IEC 27001 for information security management, International IASME Consortium on Cyber Essentials, and there's others that are out there, but these are kind of the big ones that we're starting to see in the life safety world that are being used. And then once we're putting these cybersecurity systems in, it's not one size fits all. How are you doing it? What is your life safety goals? What's your objectives? So NFPA has created different security levels, SL1, 2, and 3. Do you have equipment that is not IP connected, doesn't have, or it's non-IP communicating protocols? Or do you have IP protocols that are used in wireless, but is dedicated to your own network? Or do you have IP wired wireless interfaces that connect to the public access network? So that would set up on how do I need to mitigate the risk if I'm an SL1, 2, or 3? So in our designs now, in our systems, we need to know which one we're doing. And then along with that, the cables, connectors, conductors, the physical access that you have, the physical equipment, how is that protected? Is it in a locked closet? Do we control who goes where and when to have access to those cables, those pieces of equipment? And then something as simple as any unused data ports. We need to regulate how they're being used and block them off, and the data connection ports that we're using. So again, the building owner now plays a huge part in this as we move forward. Now we look at the software updates part. So I go through, I make a product, get it listed or certified that it meets certain requirements, I install it properly, and everybody's happy. But with everything in our world, our telephones, our laptop computers, even our automobiles, there are software vulnerabilities that are discovered, and we need to update those, fix those, patch them, however you want to say it. So it's going to now be required that manufacturers, we need to review our equipment on no less in a quarterly basis, that are there any vulnerabilities that we need to fix? Determine if there are any threats, determine the software that needs to be updated, and put that out. Now, when we talk about life safety systems, it's not like your phone or your laptop where I can just go ahead and put an update on it. I need to test after I do that. So now we need to discuss, when am I going to do these updates, and do I do it during an annual inspection or a semi-annual inspection? And just like our phones, laptops, and other pieces of equipment, it's now going to be up to me as a manufacturer to determine when my product becomes obsolete. When is it no longer viable for me to continue to update that software for cybersecurity? And then I need to inform the customer. Just like your laptop, where it will say your laptop is no longer able to support the next edition of Windows or what you're using. It doesn't mean you can't use it any longer. It just means that Microsoft is going to stop supporting that version of Windows that you have, or Apple is going to stop supporting that iOS that you have for your phone, and so forth. So now it's going to be up to me to do the same thing and notify the building owner. Some things just in our life safety world that have started to become prevalent or important is, and this is new in our code now, NFPA 72 does not require that these routine inspections, testing that I do, that I need to evaluate the existing design that a building has. That's not the job of an inspector. The inspector's job is to go out and to verify what's installed functions properly. It is not up to them to every time go out and reinvent the wheel. And it's becoming more and more of an issue to where some people go out to a building owner's facility and say, look, you need to, in my opinion, in your existing building, you need to add more devices in this area. And unless you do that, I am not going to give you a complete certificate that you've passed inspection. That's not the job of the inspector to do that, to hold the building owner hostage. So this was one of the methods to try to remedy that or eliminate that. Talking about batteries a little bit earlier, we now have the allowance in our code to allow the fire alarm control unit to be a battery tester. Some manufacturers' products already do that, where they will verify the charger test, the voltage test, the ohmic and resistance test, and a load test. So since we're already doing that, why do I have to bring in a separate tester to do all of that? So now that's embedded into NFPA 72. The only thing that a lot of manufacturers don't do today is the temperature test, verifying how much power the batteries are drawing, which causes them to overheat and then potentially need to be replaced. Another issue that's come up in our world, I mean, it's been around for a long time, it's the use of magnets to test smoke detectors in our world. That is not a viable functional test for your smoke detectors, and it has still become such an issue that NFPA 72 has wrote negative language. Usually the codes tell us when to do something or what you need to do as a minimum, not what you don't have to do. So we call it negative language, and in here we have magnets are not acceptable for smoke entry test. So now it specifically gives you that language in our NFPA 72. And when we look at systems and false alarms or nuisance alarms, one of the problems that we have been able to understand better on what's causing them has to do with construction. When systems are being installed, the buildings are being built, sometimes people put the smoke detectors in too soon and they don't protect them. And when they do that, if you're sanding, cleaning up debris, smoke, dust, and everything is circulating around, it gets inside the detector, and it might not be a problem that day. It might be a problem months down the road, or maybe even years down the road. And then all of a sudden it's, oh, this manufacturer's product has issues. And when in reality, the detectors were exposed to too much dirt and dust or in construction. So there's now requirements in the code to protect those smoke detectors when they're being installed. This is a new big change for us in our life safety world. Up until this edition of NFPA 72, there was no guidance on placing smoke detectors above 10 feet or roughly 3 meters. So NFPA has a research arm called the Fire Protection Research Foundation, and they did a project on smoke detectors going into higher ceilings. So what they've come back with is now you can go to 40 feet or 12.2 meters, and the detectors are going to be spaced the same. If you're familiar with smoke detector spacing, 30 foot is nominal spacing from what it was before. It's the same up to 12.2 meter. And 0.7 of its listed spacing, 21 feet, or about 7 meters in any direction. So a big change. First time in NFPA 72, we now have height requirements that have been added for smoke detection. Talked a little bit about acoustic leak detection earlier. So what's happened in our market is there are companies that have come out and said, look, I can put in detectors throughout your facility to let you know, pinpoint where a leak might be coming from your sprinkler system, for example. If a pipe has a fracture in it or the threads weren't seated properly, and as that water or nitrogen, if it's a dry pipe system, is escaping through the pipes, it will emit a very high frequency, and we're able to detect that, let you know as a building owner, and that can possibly save damage above the ceiling or equipment as that leak starts to progress. So if we're going to allow you to do something in our life safety systems, I have to tell you how to design it, how to install it, and how to maintain it. So this now allows that within NFPA 72. Years ago, we had something called video image detection, where we used cameras to look at an area, have discriminating software that could figure out if it was smoke or not. It didn't really take off as much as the industry thought it would. This is on the flip side for heat, and this I think will take off. When I have areas, so example on the right side of the picture, you can see what the camera sees or a person would be able to see. And you look at it, it's like, oh, there's a little bit of dust in there, but nothing's going on. But lo and behold, there's a fire growing inside that material there. So these new thermal imaging detectors can now communicate to the fire alarm system and alert you to an actual fire scenario in an area. We talked a little bit about carbon monoxide detection. Carbon monoxide is something that's not new in our world, but we're understanding it a lot more. Carbon monoxide is odorless, colorless, tasteless. You have no idea that it's in your environment, but it's kind of a silent killer. Carbon monoxide has to do with concentration, how much of it is there, and how long have I been exposed. Our human body, our hemoglobins, our blood cells want to eat oxygen and take it through our body and feed our organs. Like a child, it wants to eat the sweets or the bad stuff first and fill up on that our blood cells do the same. They want to feed on the carbon monoxide first, fill up on that before they fill up on oxygen. Consequently, our body starts to starve itself of oxygen. Our organs start to shut down. The effects are you feel like you have a cold, the flu, maybe COVID, something going on, and but in reality, it could be carbon monoxide. So a lot of research has been done. There's been a lot of work within NFPA on this, and now there's requirements for carbon monoxide detectors whenever there's a fuel burning appliance or a fuel source inside a facility. That fuel source could be oil, coal, wood, gas, propane, what have you, anything that is able to burn. So the question comes up on where do I need to put carbon monoxide detectors? Carbon monoxide has almost the same specific gravity as air, so it mixes quickly, freely, easily in our atmosphere. There was an initial study that was done to try to determine the spacing requirements for carbon monoxide detectors, and what came back was it moves so quickly and easily through the air, we don't need to worry about spacing. So we said, well, there needs to be some guidance on where do I need to put these detectors. So they came up with this. On the ceiling or in the wall, within 12 inches or 300 millimeter of the installed, permanently installed carbon monoxide source. You have a water heater or something or HVAC using propane, I need to put a CO device above that unit. Now, CO, I just told you, mixes freely, quickly with the atmosphere, but they say to put it on the ceiling because if something is burning, it's going to create warm air. The warm air is going to rise and hopefully be able to detect it sooner. After that, you need one per floor or at least one per floor or every HVAC zone, and then within 6.4 meters of any door to a sleeping area. That's it. There is not this need to put in hundreds and hundreds of CO devices like we have for smoke detectors. For notification appliances, there's now requirements on creating a standard starting voltage when we do our designs. I see manufacturers, installer maintainers, consultants using all different kind of numbers, and now we've standardized on that within NFPA on what you need to do. The same for AC. What is the amount of wattage that you need to run your speakers in a facility? NFPA talks about sleeping areas or bedrooms, and they've cleaned the language up a little bit because there was confusion on, well, what is a bedroom? And well, really what they were looking for is places where people are sleeping, we need to protect them. We need to provide them with low frequency sounders, and if they need to have carbon monoxide detectors or not. So the term bedroom has gone away and been replaced with sleeping area. A little more information, I know I'm out of time, on RAMO, restricted audible mode, and how that's to be implemented. Big change for anyone that's doing designs where we have interface to systems. The 3 foot or the 1 meter requirement of unsupervised wiring is how far you could go has been expanded. And now you can go up to 6 meters provided the wiring is in conduit or mechanically protected. 3 foot is still there if it's free wire, but it's become more and more of an issue trying to work within that 1 meter area. Messages, how we're evacuating people has been studied a lot from NFPA, the Research Foundation. And one thing that they found is how people evacuate can be affected on the type of signal they're receiving. One of the studies that was done showed that if I'm in a high-rise building and the fire alarm goes off and it starts to go, whoop, whoop, get out of the building, whoop, whoop, get out of the building, and just keeps going on over and over and over. If after it started, I shut the signal off for no more than 180 seconds, what they found was people were more apt to compose themselves, collect themselves, and they evacuated faster. So if you start to hear of a manufacturer, installer, maintainer, consultant saying, hey, let's turn the sounders off while people are evacuating, that's where it's coming from. So now 72 has guidance on that for us. And I'll leave you with this. Something was added into the code for Building System Information Units, BSIU. This was a great change for the smaller network systems where they want to have graphics capability, computers that could tie into their fire alarm network. but they didn't want to have to pay the expense for a UL 864 listed computer. And they're very, very expensive to do that, where I have to go outsource the computer, the RAM, the hard drives, the CPUs. And once I do that and I get it listed at UL, I'm locked into that configuration. I can't change anything. So what the industry did, working with UL, is they came up with this BSIU concept where it allows you to buy an off-the-shelf computer, and this BSIU needs to be listed to UL 6950 or 62368. So if you have that, and then you buy the software, the fire alarm, you still need to have a fire alarm control unit in the room where the BSIU is located, and it can only do whatever the fire alarm can do on the wall, and the software needs to be listed to do it. It is a great compromise where I want to go to a software-based annunciator interface to my system without the overbearing expense of a full-blown UL-listed computer for fire. So I hope that gives you kind of a little idea on where technology is going in our world, and I'll leave you with that. So thank you for your time.